Hey, welcome to RobbyLobby TechTalk playlist, where we discuss anything around technology, topics of PSG College of Technology. I got to meet Ray Nathan, an alumnus of PSG College of Technology, who completed the same undergraduate I did a few years after me. He went on to found successful technology-based ventures, and then he successfully pivoted into food industry. The industry was alien to Ray. He was passionate about food and impact on the human body. And from his personal experiences, he traveled extensively and unique understanding of a critical aspect that mattered for food. This podcast was recorded as a presentation for a technical symposium conducted by our alma mater. But I thought this will also be interesting for people like you. Hope you get something out of it. Enjoy. Hello, students, faculty, and alumni of BSc Applied Sciences program. I'm so glad to be with you. It's about 32 years since I graduated with BSc Applied Sciences. Since then, I went on to do MCA and Masters in Applied Statistics in US. But the BSc degree was always close to my heart, simply because it was probably the toughest course around at that point in time. It created a culture of curiosity and helped us build resilience. That has been the foundation of pretty much my life as I pivoted in various career things. I started with engineering, building flight simulators, then went to supply chain, then worked with e-commerce. Now I'm working with biopharma. If I look back at the thread, what helped me carry through these transformation, it is the foundational sciences and engineering programs. So I'm really grateful for the course. And today we wanted to share the science of success, like how the foundational sciences that enabled us from PSG helped us to carry on through our journey. And I have an outstanding alumnus from our program from the 96 batch, Ray Nathan. Hey, Ray is founder and CEO of Newty. Am I pronouncing it right?
Correct. We call it
Tasty?
nutritious and tasty.
How are you doing?
Good. How are you? It's great to be
Here.
here. And hello to all the students who are listening. I'm pretty excited to be here. And thanks, Robbie, for the opportunity to share my experiences. Hopefully, there is something for everyone to take away.
Ray has had an amazing journey from tech. He has started multiple companies with very successful outcomes in the technology space. But in the last decade, he has been passionately doing something that is so foundational to humanity. It's deeply rooted in science, but also something socially very responsible to do, especially given the times. I'll not give away much because I want him to share about it. So, Ray, take it on.
I'm a proud alumni of PSG. Six. It's when we graduated, and I'm not very far behind you. So it's been a great, amazing journey, less frequently. And
Mhm.
back then, for many reasons, having that flexitarian diet gave us a kind of ability to actually balance between what is great, what you feel good, as opposed to what is good for you. What do you feel good instantly, as
Mm.
opposed to what is good for you in a long run? Constantly paying attention to how it tastes like, and
That's
not
right.
less so on how it feels like, which is what we found in India, which is where people started consuming a lot. And unfortunately, that something has been, but we evolved, and the change has to come from within. And that's critical actually, because you can't really be preaching. We as humans are programmed to appreciate things that are fresh, but industrial food production over decades
Yes.
transformed it and hijacked some of those freshness concepts and introduced
Hmm.
what is called a richness concept. So they started putting rich foods on our plate and overwhelm our senses. And it took away what was fundamental to our nutrition, which is freshness. And when richness comes in, you forget the freshness aspect of the food, and you start enjoying food for what it could be, overwhelming your taste buds with sweetness, for example, and it could be certain synthetic flavors, and which you start liking a lot more because it overwhelms your sensory capabilities. Now that's fundamentally started influencing the way people actually eat. And These are some of the outcomes of my journey over a period of time. I was living in New York between 2014 and 2016 when I came across a technology called high pressure processing, which was revolutionizing the beverage industry at the time by producing what is called cold pressed uh, juices. This technology helps to retain the freshness of food. We looked at that, and the application of that technology was largely
Can
in
you
beverage.
can you explain what exactly it is, the technology?
High pressure processing is based on two sets of scientific principles: La Chatelier principle and isostatic principle. La Chatelier principle, in the context of high pressure processing, states whenever pressure is applied to a system in equilibrium, the system will react to counteract the effect of the constraint. Traditionally, the way to preserve or extend the shelf life of food is using thermal processing technology. Industrial food production came into being because there is rapid
urbanization,
you wanted to feed people,
and
make food easy and accessible. How do you extend the shelf life so it is accessible to people? I understand getting fresh food, cooking it in the restaurant, and delivering it to customers is one game, but you may not, for many reasons, have accessibility to a restaurant. In many areas in Western countries, you probably would not have access to a restaurant constantly on demand. Even if you do,
restaurants are
not preparing food from scratch as they conventionally do, because the scope of work involved in the restaurant is so large that it becomes harder to actually prepare everything from scratch. So it starts with a few packets of ingredients and semi-prepared food from which you get the final food. There is what is called packaged food involved in the food industry, like it or not. That is how the entire ecosystem is now thriving. If I had to put it in the Gen AI context, like you don't need hundreds of foundational
models. You just need one, or
a few from which you build various applications.
the key is to figure out
A way to keep these
foundational elements
intact so you
can
regenerate the
applications.
in the flavor that people like as quickly as possible. You want them to sustain. And the restaurateurs and the chefs also need a work life balance. They can't just be slogging endless hours in the kitchen. For many of these reasons, semi prepared or packaged food is critical, and
Requires
what is called its shelf life. A shelf life tells how long the food can stay intact, retain
freshness and
how long before spoilage organisms kick in. To extend shelf life, the conventional technology widely used in packaged food in most countries, including India. Thermal technology essentially involves heating the food to over 100 degrees. When you do that, it annihilates the bacteria, the harmful pathogens. And because they can't survive that, most of them die at 100 degrees, 80, 85 degrees Celsius. This offers that possibility of a longer shelf life. And I say possibility of longer shelf life because
it's
dependent on the type of food. And there are other aspects such as pH value of the food, which also
determined.
the shelf life. Now, the challenge of food over 100 degrees, you not only destroy the bad pathogens or the bad actors, but you also end up destroying the good actors, the good bacteria. A lot of probiotic stuff is also destroyed in the process. Essentially, you get the food which is less appealing to people. As a result, they start adding more salt.
This
Is why you find such packaged food is salty and it's imbalanced in terms of nutritional properties. To make up for the loss of freshness, producers do add different things. The high pressure processing technology follows what is called cold pressurization. This uses pressure based technology to neutralize the pathogens by applying pressure. It was proven by a French scientist, Pascal, that you could apply pressure and destroy the cellular structure of the pathogens in the food, they're disrupting the cellular structure of the pathogens. So you deactivate the pathogens. You don't actually impact the good bacteria and the freshness of the food. Thereby, you retain a longer shelf life. This was demonstrated in the 50s, and because pressure required is so high, it has never
progressed
from an experimental stage
to
practical applications. To put it in context, the pressure
needed
to treat food
and
achieve sterilization is closer to the pressure found in the deepest part of the ocean, the Mariana Trench. That level of pressure is hard to create a vessel that can withstand that pressure, figure out how to package the food, apply pressure and any deformities. So
there's a
whole series of experiments needed to determine the usability, viability of the technology.
after
All that
you need to
figure out
if it
viable for consumers. How much
Mhm.
is it going to cost people to pay for? This is something that is scalable. So this was a largely an experimental technology, which was based on, as I mentioned, those two fundamental scientific principles, La Chatelier principle and the isostatic principle. The isostatic principle, on the other hand, talks about how when you apply pressure, it's equal from all directions. So pressure is transmitted equally across all directions. That ensures sterilization of the food in a complete sense. So it is not partial sterilization, but it's sterilization of the whole packet of food. These are the two fundamental concepts behind
And
it.
how does it
high-pressure
differ
processing
from just
technology.
plain freezing?
When you freeze food, you reduce the microbial activity and nullify it. Deep freezing, for example, will completely freeze the microbial activity. It it also changes the texture of the food when you freeze it. It goes from whatever state it was, liquid or semi-solid,
to a
solid state. If it's completely frozen, the microbial activity is nullified, much like high pressure processing, but it involves a change of texture. If
you
you were to have food like, for example, you could actually,
freeze it
by doing so, you change the texture completely. When you thaw it, the regeneration is not 100% closer to what it originally was. There is an added water content to it. The critical factor is defreeze it. The microbes which
where
previously frozen are now brought to life. It's only a deactivation which occurred due to the state of the food from liquid to solid, which again comes back to life. It doesn't sterilize the food as such. It only changes the state and temporarily deactivates. High pressure processing, on the other hand, you could take a packet of sambar and apply isostatic pressure, neutralizes the pathogens, and when you take that finished food out, what you find is a packet
which is now good to be in a
refrigerated state.
Okay.
It need not be frozen, but it's good to be kept in the refrigerated state for 90 days. It is as fresh as one which is freshly made because it brings
the microbial count down to almost
zero, no detectable microbial
or
pathogenic activity post high pressure processing. This is as good as putting a very hot sambar on your table. But you can't say the same thing about frozen.
This has been for 10 years, right?
We've been on this journey for
8 years
nearly
now.
8 years. 8 years ago, we decided to put our heads together and get into the food industry. I've been on this journey of exploring the food space and experimenting various diets for over 10 years now. We hunkered down and said, okay, this is something that we would like to go deeper into and make a
I'm
business
sure
out of it.
it's probably extremely courageous to get into something as big as the food industry, starting from a small, simple experiment, proving to yourself the technology works. Then, as you said, talking about the scalability, then business viability, and persisting all the way through. Do you think any part of your early education helped in this process, especially what we went through in applied sciences?
This is an age-old industry, and you are essentially tackling long-standing players who've been in the business for so long. It's not easily approachable for someone from technology to go into a kitchen and say, hey, I'm trying to define what you've been doing for so long. Bringing a structure into what is traditionally chaotic in the kitchen process, and understanding an industry
That
is largely unstructured, requires a fair amount of understanding of science, and confidence that if you follow the path of science, truth will eventually solve most problems in the world. My co-founder, Naveen, was my
Really?
classmate in applied sciences. He's lifted heavier weights than me when it came to solving some fundamental problems we faced in the early days of food production. What kept us going all these years is our ability to understand the scientific aspect of what we are doing and then approach the problems scientifically. We were extremely confident that the
path.
we have taken up has
Mm.
been proven theoretically. So
It's
practicality that we needed to solve. Once you know theoretically it works, then you put on the hat of an experimental scientist and you start doing iterations. Use
take,
a systematic approach to dissecting a problem.
which
Could
involve a
process of elimination.
Quite
These are some of the approaches we have taken. When I look back at the food, it's about physics, chemistry, and engineering.
all that in motion with
It's the physics of how things work
that.
actually prompted us to look into it. And the chemistry of food is critical. Now we need to engineer a solution around it, which is what we did. The whole app we built in partnership with our manufacturers, something it has never been attempted at that scale in India. Ours is one of the largest food production facilities that uses high pressure processing technology in Southeast Asia. It's in Hosur, outside of Bangalore. We put that plant in, set up the plant in 2018. Just when COVID hit, we were deploying the first large high pressure processing equipment. The entire installation went through without any personnel from the manufacturer on ground. Some of those times we had to put on the hat of an engineer trying to figure out the nuts and bolts of things, literally. A lot of that learning came through from the education we had and how we felt confident that we
Good.
solve the problem by taking a systematic approach.
With all these pivots, you should have had an inordinate amount of curiosity to pursue and patience. What do you think is the role of curiosity as a characteristic in all these things?
Curiosity is something which everybody possesses. We are all curious about something. Scientific curiosity comes out as a process of learning. If you're a student of science, you become curious about how things work. For example, you
Look,
have a real world problem and
try
to understand how things work.
taking
An outsider approach, which is where disruptions usually come in. We are no smarter than an insider in the food industry. As I always say, I'm maybe a food tech entrepreneur, but I'm a terrible chef. People who we have, and I learn from them to think in a certain way, and they continue to do what they do best. They're curious about the use of ingredients,
and
various cooking techniques. The curiosity among our chefs is equally good.
whatever your
Chosen discipline could be, you can be curious about it and go deeper into it. And that's how you become more creative and successful in what you do. An interesting thing about scientific curiosity is when you step back and look at things in totality, you start thinking about, okay, how can I approach things in a fundamentally different way? That requires a much broader understanding of the building blocks of science. If I were to say, hey, this is high pressure processing technology and it's a machine which you put packets in and comes out sterilized and it's great, a businessman might like it. They may not fully understand the scope and scale of what we could do with that. This technology has been there for over 25 years in the mainstream. But when we approached it, it was a novel application of that technology. That is what earned
us
a patent. The way we approached it was to take a more scientific approach,
And
bet on the potential application in this Indian food space. That was greatly enhanced by my understanding of how it works. So if it works for beverages, which
have
the high liquid content, it should work for curries, which also
have
the high liquid content. At that point in time, it was never applied for food, let alone curries. Curiosity, which drove me to understand how it works, was also a catalyst for me to come to the conclusion that it could work for a certain other set of applications. And then you start understanding how you could make it work. Then you're confounded with different problems. Will it work as accurately as possible? Is it as effective?
this.
Requires an understanding of the scientific principles behind it. In the early days, we were talking to a bunch of investors who have excellent pedigrees, Harvard and IITs, but even some of them fail to understand the scientific principles behind it. Not to say they don't understand, but they may not have looked deeper into it. So they may have basic questions like, how do you make it work? There are times
When
your entire thesis is questioned
because of the
lack of scientific understanding behind the technology. But as we have shown, we approached it step by step. And when we put out the product, it speaks for itself. DeepSeek published their research long before they published their product. People are like, oh, yeah, it sounds like a good theory, but I haven't seen the product yet. But when you push the product out and then you talk about what thought process has gone behind it, it makes it a lot more interesting.
This is more for students who are pursuing their careers, and I'm sure many of them want to be entrepreneurs like you. Having the scientific mindset, even a solution in their head is one thing, but turning that into a successful solution may require a different set of skills. Is there anything particular that they should be mindful of?
One of my major learnings here is just because there is a great technology or what we may seem to think of as a great application of technology doesn't necessarily mean there is a problem statement in the market that suits the product you're putting out. We need to be mindful of market reality, widely known as product market fit. As much as we achieve the scientific breakthrough, is there a real need in the market for it? Is there an intrinsic need in the market for that product? And if you're offering that solution, is this an incremental improvement or a giant leap? Then you start asking about yourself if there is enough value that you're offering to consumers. Are you creating a product
that
is marginally better or significantly better?
are you
Offering it for a marginal value or a significant value? These are certain market forces and economic aspects
that
innovators need to be mindful of when we approach a technology-based solution to the problem. And the common pitfalls are, okay, I have a superior product and not being able to define how exactly are you superior? Do you have metrics around it? Can you just give me some data points associated with that superiority? And why would people be paying for it? We used to, in the early days,
make
the mistake of
telling
people, we use high pressure processing technology to make this food. And people are like, oh, does it really matter to me? How do I feel about it? How much is it going to cost? And folks are interested in a product, how well it is engineered. You always have these early adopters, and not being misled by the early adopters is really important for entrepreneurs or those trying to solve problems. They need a balanced input from a wide group of audience. It's important that if anyone is building a solution, they have a diverse profile of people in their team or as a focus group. They can talk to these different groups of people and get their feedback in terms of what each of these individuals see as value in what they're trying to build, and not
make
a concentrated bet on a few groups of people. They are, at the end of the day, consumers that pay for a product, and often it is a balancing act. You can't just put on the hat of
a
a common person
right
after you come out of a lab and
say, hey, I'm going to think of
average Joe. That might be really hard. The best way to offset that risk would be to have a diverse pool of people who you can bounce off your ideas and solutions during the process.
Super critical, if you're working on something, it's easy to lose track of that.
The value of the solutions we build is also very critical to measure in terms of perceived value as opposed to real value. This is again comes down to market forces,
Which
can be approached systematically. We need to be mindful of.
there are
Number of other market forces which we may not be able to control. There are secular forces and headwinds which we be able to control. To a greater extent, by taking a systematic approach, you can offset risks. These risks
and
enhance your chance of success. It is not guaranteed, but it will definitely enhance your success. When you stay on track, eventually, as the clouds
clear.
people will start seeing the sun. In our case, this largely became true when we started putting the
Product.
out. Initially, our focus was largely on the tech part of what we did. Then we let the
Product.
speak for itself. People started paying attention to it. To put it in context, I can give you an example where the biryanis we produced in our production facility were high pressure processed. We took an approach where the portions are portion controlled. They're very well balanced. You have a set defined calorific value, and it is consistent
Because of the nature of the production.
process, which is high volume. It is more structured, done like an assembly line production. We were able to define the calorific value and maintain the taste consistent across batches of food that we prepare, as much as they are made in small batches by chefs using set recipes. We are able to give that McDonald's experience even in biryanis. So you go there and take a burger and take a bite, and it's consistent. If you have a spoon of biryani every day, and from every different packet you open up and have it, it's just fresh and it feels consistent the same way. That we felt was an outcome, which is not something we had originally hoped or
Attempted.
but it came through the structured approach we have taken. And that is what actually helped us to gain the market. In most restaurants, when you prepare something, you could actually just get it right, or you can make mistakes. The biggest challenge in the restaurant business is consistency of food. And how do you make food like Indian food, which is complex and requires good skills, consistent? That puts an undue burden on the chef. But if you're solving this problem in a matured market where you don't have access to as many skill chefs, or skill chefs are very expensive, and folks cannot be expected to slog long hours in the kitchen, how do you create that kind of
Consistency.
The way is to produce it in a very controlled environment and systematically. So we went above and beyond
Shelf life extension is
part of using high
pressure technology, but we
also looked at how we could produce food in a more systematic way. And
reinvent
the supply chain
this.
is critical, because now that we are producing food in large volumes, we can source good quality ingredients directly from farms. By doing so, we are seeing economic value being added, an economy of scale when you produce in higher volume. So we are buying from farmers
In
large volumes, and that offers a greater benefit to
customers by
ultimately
passing
pass a value onto
them.
So not only our food is actually good and healthy and balanced, but it's also cheaper than restaurant quality food made fresh in the restaurant. These are all interesting dynamics which played into the business and were critical for success. The main element could be the high pressure processing technology, but what is driving the momentum here, the supply chain advantages and the economy of scale, and being able to ultimately offer greater value to customers, that has created a mass adoption.
That's beyond technology. To the consumer is the critical thing. There are so many elements focusing on the value. That's outstanding. And the fact that you can put a label to biryani, that's out of this world, a consistent food label.
One of my first experiences was when you're eating your food, what is the best indicator for you to actually say that you have consumed enough? Yes, you can rely on your senses of how you feel. I feel good. But if the food is delicious, like Indian food, it's got everything for your taste buds to start dancing. You're eating more than you should. Because the food is great, people consume more. But hey, how do you know when to stop? So I was like, okay, let's put a calorific value to the food. Let's say this is how much you should eat. I was a fan of this box meal. In 2018, we came up with
These.
box meals with a calorific value. We got it tested from the lab and spent a fortune to do that in India and in Bangalore. We were the first to actually do that, put the sticker on the packets and give it across to customers. People liked it in Bangalore, but it also created a sort of a
Packaged.
food feel
They were.
like, oh, so it doesn't come fresh from the kitchen. We also understood that consumer psychology is really important. You could do what you think is scientifically right, but consumer psychology is something that you need to be mindful of. Changing consumer psychology is a long-term game. As an entrepreneur, you may not have that kind of a bandwidth to play for that long. Most of us go for short-term gains, and the market can quickly misrepresent. And food industry is, I have to say that it's a truth. People should know it. So you right and so when we started doing this, it was out of the main reason that I in the process of consuming a lot of going back to India and trying a lot of Indian food, which I have not done so in growing up, because back then we did not have access to online ordering as much as people do right now. So we were restricted to home food and occasional restaurant food, very rarely. And so I could see that trend has shifted. And as a result, people talk about biryanis a lot. And so I started looking closely at what is actually the calorific value of biryani. And it was somewhere around 700 to 800 calories on average from back then from restaurants. I have no reason to believe it would have gotten any less, but the restaurants were trying to please customers by selling more biryani as opposed to selling quality stuff of what they actually need. So you are getting your wishes granted, but not necessarily that's a healthy wish for you. Each of us
Pass.
different requirements at different times of the day. You could actually keep going with one.
Biryani.
As long as you know what you're putting in, balance your intake. So we decided to put that information out there for customers to decide and make customers the choice of what they should do. So we did that in 2018, and we were pioneers when we did. And 2020, I think 2019, 2020, COVID brought a lot of realization to customers, and even the regulators woke up and they started enforcing regulations on having the calorific value of food displayed for all restaurants. So now most restaurants are required legally to put that information out. I think only the Western restaurant chains that are doing that. I'm not sure how many Indian restaurants do that, but the food tech platforms have also cleaned up their act and they're asking restaurants to get that information out. But the challenge here is when you get that food from a restaurant, is it consistent? They could prepare that food one time with a certain level of calorific value, but will they actually replicate that same thing over and again? That's the challenge for the restaurants, and that is an opportunity for us.
We've come to the end of the time, but I do want to ask you one question. As somebody who pivoted at the evolution of technology into so many things, if I ask you to put on a hat of a fortune teller for especially students who are just graduating with all the changes, including DeepSeek and things like that going around, is there anything that the students should focus on? Or how do they prepare for the impending chaos or change or things that are coming our way?
It's a great question. We're always caught by things that are transpiring on a daily basis. It could be overwhelming for students. For the students, is to stay calm and stay focused
Focus.
on understanding the foundational sciences and the building blocks of the science. Ultimately, applications can change from time to time, but the scientific principles behind them don't change. So if you understand the crux of the knowledge and the scientific principles, you can always redefine the applications over time. If you are looking at how
To
harness AI. You could harness foundational AI as new foundational models come out, but having an understanding of how it actually works and some of the building blocks of it is an essential skill which you can acquire during these times when you are in the university and when you have access to excellent professors who you can talk to. This is a time where you can spend understanding the science behind it, because once you're out of college, you're most likely going to be distracted. You're going to be looking at various applications of science. Your understanding of hard physics, math, and chemistry is going to be limited
Focus.
on the foundational sciences.
Yes.
You can put AI to effective use to help you understand the foundational sciences and not get caught up in the
Evolving.
applicational aspects. Improving your understanding of sciences is critical.
AI
Can help you
learn and
structure your thoughts. Structuring your thoughts is the most critical learning you could do by approaching it systematically. Build on your learnings. Innovate.
that reinforces them.
Continue to build on what you have already learned and then progress forward. This is an exciting
Time.
for all of us, and putting AI to use in learning is critical for many students to harness its power.
And lay the foundation right when you have the opportunity, because once you leave college, you might not have that.
I look back and I feel my understanding of quantum mechanics, for example, would have been much better if I had certain imaginative skills, which I was lacking back then. Some of
Those
gaps can be filled by
AI enhancing your
understanding of foundational sciences now more than ever before, and this is the opportunity that young folks should actually try to focus on, as opposed to building application level usages, because the foundational knowledge is not going to go away anytime soon, and that is going to guide you all during your career of whatever you choose in future.
Thank you. That's a great way to finish. Thanks for joining us. It's been really insightful hearing about this. And also, we're really glad to see our alumni going out and succeeding in various fields, especially in an industry like food, because a lot of us who are in engineering do not in fact, have a disfavorable opinion about anything to do with biology or life sciences. So it's really refreshing to see you touching something that's so fundamental for survival and taking a fresh look. I'm hoping and wishing you students who are listening that many more people like Ray would come out and contribute to society and humanity. Thanks for taking time to listen to us. You want to share anything before we wrap up?
Well, thank you again for the opportunity, Robbie. I'm so glad to be here talking to everybody, and wish you guys the best. And you're in the best place, you're in the best company. Feel free to reach out to us. So
Thank you.
all the
Thanks,
best.
man.